Hi everyone. Yes, so today will be again like solving the interview series problem. But before that, let me know how did it go? How were the questions? Did you like the questions? Did you face any difficulties? Let me know about these things, and after that, we'll start discussing the problems. Meanwhile, let me just my yeah. First, let me know if I'm audible properly. From audible properly, and then let me know how did the contest go. Were you able to solve all the problems? How was the questions? Did you like them? Did you not like them? Any other thing that you want me to know? You can definitely like let me. So did you like the questions? I believe many people did. How many people gave the contest? You're out of submission. Nice. Yeah, I think many of you actually appeared for the contest. Let me know how did. While we wait for others to join in, let me know how. And did you like the problems? Did you not like the problems? Let me know how did the contest. How were the problems? How were the difficulty? Like how did you find the difficulty? Were the problems too difficult, too easy? It was okay. What do you think? Write something in the chat. Otherwise, I'm not sure if I'm audible. Can check if I'm. I think I'm right. Okay. Seems like no one is in a mood to chat. That's what I see. Just check. Sir, can you please tell me how to optimize my code? Which one? Yeah, optimize your code. I'll discuss the solutions, right? So I think you will get a fair amount of idea like how. So I'll definitely discuss all the solutions to all the problems that are there. I'll try solving them. So I hope that I can, and I think that will make clearer. Okay. Okay. Let's without wasting time. Let's start with the first problem. So the first problem is count the substrings, right? Uh, Now, what is the question? Given a string S, the task is to count the number of substrings which contains equal number of lowercase and uppercase letters. Okay. So you have to find what is the number of substrings contains equal number of lowercase and uppercase letters. You are given a string and you have to find what is the number of substrings that contain equal number of lowercase and uppercase letters. Right? So GEEK. What is the number of substrings that contain equal number of lowercase and uppercase letters? GE is a substring that contains equal number. EK is a substring and GEEK is a substring that contains equal number of uppercase and lowercase characters. Right. So that's why the answer is 3. In the second case, we have Women's Day. So WO, this is one of them. SD can be one of them. NSDA can be one of them. ENSDAY can be one of them. So total there are four substrings that contain equal number of uppercase and lowercase characters. Writing code in Python needs more optimization. Is that so? Generally, in contests, the time limits are adjusted for different languages. But again, like yes, I agree with you. Python is slower than other languages, so it might happen that in some contest, if it's not adjusted properly, Python solutions might give TLE. So there is a chance around that. Okay. So this is the question. Now, how do we solve this? The constraints are pretty weak, right? The constraints are pretty weak. So I think it is very easy to solve for you. Can anyone tell how would we solve this? Can anyone tell how can we solve this? So the question I believe is clear and you have already read it. It's given a string S. You have to find what is the number of uppercase and lowercase, number of substrings that contain equal number of uppercase and lowercase characters, right? And we are given S is 10 to the power 3. So can anyone tell how can we solve this? It's pretty simple question. Anyone? Uh, I believe like 10 to the power 3 everyone can do. So what we can do is we can go for all the substrings, and for every substring we can see what is the number of uppercase and lowercase characters. We can easily do that. And yes, exactly. A simple navigation, j equals to I plus 2, and that will give us order of n square, right? Order of n square complexity. But I'll make this a bit trickier. What if S is less than equal to 10 to the power 5? If the length is less than equal to 10 to the power 5, what can we do? Can anyone tell what we can do if the length is 10 within 10 to the power 5? Let me just rub these things off. What if the length is less than equal to 10 to the power 5? What can we do then? How can we solve this? Any idea? I believe the brute force is clear with everyone. The brute force is just iterate through all the sub-arrays, and for each sub-array you will compute what is the number of lowercase and uppercase characters. You can easily do that. Like when you are actually generating the sub-arrays, you will make sure that the sub-arrays are generated from left to right, and you can maintain a running count of the number of lowercase and uppercase characters, right? So, and then you can compare if they're equal. So you can definitely do like that, and the complexity will be order of n square, where n is the length of the string. What if the length of the string is less than equal to 10 to the power 5? How can we do it? Anyone has any idea how we can do it? Just making this a bit more challenging because this is a pretty simple one. Any ideas on how we can do this? Waiting for your reply. Uh, can you solve it for 10 to the power 5, or shall I tell the solution? Let me know. Shall I tell the solution for 10 to the power 5, or can you solve? It's just a simple trick that you have to do, and you can easily solve it. Like after that, it's nothing, right? After that, there is nothing. You can easily do it, but it's a small trick that you have to do. And here I'll probably write the code for n squared only, because order of n code will be pretty simple. Like you can definitely find related problems. I'll definitely suggest you related problems, but I want to discuss this trick with you, that how we can do it in order of n. J equals to I plus 2 shall work. I don't think so, right? Like we have I loop which is running for n. J equals to I plus 2, that's also running for n, so it will be n squared, right? So basically J loop will be running for I equals to 1, it will run for, let's say, n minus 1. For I equals to 2, it will run for n minus 2. Like that, it will run up to 1 length, so it will be n squared, order of n squared eventually. So that will not work. Okay, let me tell how we can do this. Very simple trick. What we can do here is, let's say let's take an example like geeks. Sorry, what was the example? GEEK. The other way around. GEEK. Can we do something like this, that when we have a lowercase, we can add a value +1. When we have a uppercase, we have change it to -1. Can we have lowercase to be +1, uppercase to be -1? So if that's the case, what the array will be? 1, -1, -1, 1. What you have to find, what is the number of sub arrays that has sum equals to 0? That is what you have to find, because sum equals to 0 means the number of lowercase will be equals to number of uppercase, because lowercase is +1, uppercase is -1. So the sum equals to 0. We have to find how many subarrays are there that has sum equals to 0 in this array, right? So if you see, there is one subarray, this is 0 sum. Similarly, this is 0 sum, and this entire array has 0 sum. So how many subarrays there are there with 0 sum? So basically now the problem, after you have done this, the problem basically reduces to find number of subarrays with 0 sum, right? I'm pretty sure that you can do it, like you can definitely get it done using prefix sum or something similar. So I'm not discussing about this. So let's write the brute force code only, and try to solve this in order of n time, right? Now it will reduce to order of n, because finding number of subarrays with 0 sum is order of n time. So you can definitely reduce it to order of n. Okay, so let's write the brute force solution only. What we can do here is, what do we want? We want number of uppercase, right? So let's maintain number of uppercase equals to 0, num lowercase equals to 0, right? And int answer equals to 0. Let's go for it. So for int equals to 0, I less than s dot size, I plus plus, and for now we will maintain the j. For in j equals to I, right? J equals to I, j less than s dot size, j plus plus. Okay, so if s of j is greater than equal to, is if s of j is greater than z, then it is lowercase. S of j is greater than z, then it is lowercase, else uppercase. So in this case we'll do num. Okay, let's reset the values here as well. So instead of doing here, we can do it inside this. So let's have this here, and what we'll do, num lowercase plus plus, and num uppercase here plus plus. And for after every iteration, we'll check if num lowercase is equals to num uppercase, then we'll do answer plus plus, simple, and finally we can return answer. Right? So this is a brute force solution. We are just going through all the subarrays and then maintaining the number of uppercase and lowercase. So this is returning correctly. So let's submit. So is this clear with everyone? Anyone has any doubts with this? Let me know if anyone has any doubts with this problem. I can do some dry run if you want, but let me know if you need that, because it is pretty simple. Let me know anyone has any doubts with this. Then I'll dry run this for a small test case maybe. Or let me just dry run this for a small test case. Wait, let's just go for the small. So let's take the code. So let's say we have geek, right? This one. So for every starting point, I is a starting point, and then we are resetting num uppercase, num lowercase. So let's consider the starting point G, right? Starting point G, how many subarrays are there starting at G that has equal number of characters, right? Uppercase and lowercase. So num upper equals to 0. Let me write it as upper instead of num upper. Num upper and upper will be same, right? Uppercase is 0, lowercase is 0 initially, right? Okay, so we start off at j will be equals to first G, like j starts at I. So s of j is greater than capital Z. Yes, it is small letter, so it is greater than. So we'll do num lower plus plus. So lower becomes 1. Now we'll check if num lower equals to num upper. Upper is 0, lower is 1, so it is not equals. So we'll continue. J will move to the next position. E. It is greater than or less than. It is less than Z, less than capital Z. So we'll do upper plus plus. Now in this case, num lower is equals to upper, so our answer is increased to 1, from 0 to 1. John, I have already told there is a better approach than n square. It is order of n. What we can do is lowercase can be treated as +1, uppercase can be treated as -1. Then the array reduces to 1, -1, -1, 1, something like that. What we have to find number of subarrays with some 0. This problem is already present in Geeks for Geeks. You can look it out. There is also video solutions for that. So this can be done in order of n time, right? Using prefix sum. Number of subarrays with some 0, you can do it in order of n time using prefix sum. Okay, so it can definitely be done better than n. Okay, so E is done. Now we'll go to the next E, and answer has been increased, so we'll go to the next E. Again, this is less than capital Z, so we'll increase upper. Upper becomes 2. Is upper equals to lower? No, because 2 is not equals to 1. And finally we'll go to K. So K is lowercase, so this is num lower will be plus, right? Num lower plus, so it will be 2 2 and equal, so answer will be increased to 2. So see, starting at G, there are indeed 2 subarrays that has equal number of uppercase, lowercase, G E and G E E K, right? So these are the 2. So that is how this logic is working. I believe it's clear with everyone. And if you want to optimize it as the homework, try optimizing it to order of n using the zero sum concept, right? Let's go to the next one. 30-50 submission accuracy for this is less. So for this accuracy is more. Geeks island is represented by an n cross m matrix mat. The island is touched by Indian Ocean from the top and left edges, and the Arabian Sea from the right and the bottom edges. Each element of the matrix represents the height of a cell. Due to rainy season, the island receives a lot of rainfall. The water can flow in 4 directions: up, down, left, right. From one of the cell to another one with height equal or lower. So it can flow from a cell to another cell if the next cell has a height equal to the current cell height or a lower cell height, right? Or a lower height. You will need to find the number of cells from where water can flow both to Indian Ocean as well as Arabian Sea, right? So basically we are given a like this, and if you see, the Indian Ocean I think is on the top left. Indian Ocean is on the top left. So here we have the Indian Ocean on the top and the left part. The Arabian Sea is on the bottom and the right part. And what do we want? We want the water to flow from a given like what are the cells from which water can flow to both Indian Ocean as well as Arabian Sea. Like rainfall is happening, right? Rainfall is happening, so water is getting stored on the buildings. It will overflow to both Arabian Sea as well as Indian Ocean. Now how can we do this? See that for every cell or every cell, we have to travel through some of the cells to reach to one of the seas, right? For example, one is adjacent to Indian Ocean, right? But we have to travel from one to the Arabian Sea. So that's why it might be possible for some of the cells it is not possible to travel to the other sea. Okay, so for those reasons it will not be included. So for example, in this case, let's understand from one can we travel both to Indian Ocean as well as Arabian Sea. The condition is that it can only move to a height equal or lower. It can only move to a height equal or lower. So from this one, is there a lower height? Is there a lower height possible after 1? 3 is not lower, 4 is not lower. So from 1 it will be stuck here only. It will only flow to Indian Ocean, right? So 1 is not possible. For 3, can it flow somewhere? 1 it can flow to 1 and then go to Indian Ocean, or it can go to Indian Ocean on the top, but it cannot flow through to Arabian Sea, right? For 4, let's see. For 4 we can go to this 4. For 4, because height should be greater than or equal to, right? So from 4 it can go to this 4. After this 4 it can go to 1, right? It can go to 1. From 1 it cannot go anywhere. Okay. Okay, but for 4, if we see, it can go to Arabian Sea, Indian Ocean directly, right? For 4 it can go to Indian Ocean, Arabian Sea easily. For this 4 also it can go to Arabian Sea because it is on the right hand side as well. It will go to the Arabian Sea easily, and to Indian Ocean it will go to this 4, this 4, and then it will go to Indian Ocean. So for both of them it can reach. For this 4 also it can reach, because from 4 it will go to this 4, then this 4, then reach, or from 4 to 2 then it can reach, or 4 4 and it can reach the Arabian Ocean as well. Arabian Sea as well. 6 6 we again same path, 6 to 4 4 4 and then go to both of them. For 5 what we can do, for 5 we can go to 1 1 and then directly go to Arabian Sea. For Indian Ocean what we can go is 5 to 4 4 to 2 2 to Indian Ocean. So it can go from 5 as well. I was trying from top right to bottom left corners first BFS, as they will have water flowing to both top right and bottom left. Top right and bottom left. Yes, they will have water flowing to both of them, but it might be like, let's say there was a 6 here, right, and there would have been a path like this to Indian Ocean. So in that case you might have missed. So essentially I think you got the idea, right, how actually it's traveling. So what we have to do is we have to find the reachability, right? We have to find the reachability. So just treat each of them as nodes. Each of the cells will be nodes. They are connected to all the adjacent cells. Like it is connected to this, this and this. Now for both Indian Ocean and Arabian Sea, we'll compute this separately. What we have to find is reachability. If it is reachable from Indian Ocean to that cell, like we'll do the reverse problem. What we are asked here to do is, from that cell we are going to Indian Ocean or Arabian Sea, but we'll solve the reverse problem. That is, we'll come from Indian Ocean to that cell. Can we come? And for that the condition will also be different. Like height was equal to or lowered. Here we'll take upper height, because if from 3 it can flow to 5, because from 5 it was actually flowing to 3, right? So from 3 will move to 5. Yes, trial. Okay, so that's what we have to do, right? So we have to treat each of these cells as nodes. We have to then find the reachability, like whether from here we can reach to all of these cells. Now as we are computing the reverse path, the condition also has to be greater than equal to, right? The condition has to be greater than equal to, like from 3, if we are starting from the C, right, from the C we go to 3, then we'll go to 5, because if the water falls at 5, it can go to 3 and reach the Indian Ocean, right? So we will have to make the condition the reverse condition, and we have to see the reachability. We have to find the reachability, like if each of the cells are reachable from Indian Ocean. Similarly we'll do the same for Arabian Sea, if each of the cells are reachable from Arabian Sea, and then we can actually like see if it is reachable from both of them. One way to do it is, you can treat these as the starting nodes. You can treat these as nodes, the Arabian Sea and the Indian Ocean. Or you can see that from Indian Ocean these cells are directly reached, right? The top and the left cells are directly, they will always be reaching from Indian Ocean. We can always travel to them, right? So just start from these cells and then see what is the reachability that you get, right? We can start from these cells and check what is the reachability that we get. So we'll use a DFS for this. A simple DFS would do. Let's try to write the code for this. Flow, or we can do a BFS as well. It completely depends on how you want to implement it. But we can do both DFS as well as BFS, right? Okay. So let's start. Okay. Let's maintain 2 arrays in int, right? So vector yes, we are visualizing. I think like the condition is clear, right? If the condition is not clear, I'll just make this condition a bit, like I'll try to explain on the condition a bit. So if the condition is not clear, just think about it. Let's say water has dropped on 5. So from 5 it can go to 3, because height of 3 is less than 5. Then it can go to the Indian Ocean. Now what we are doing is, we are starting from the Indian Ocean and we are seeing the reachability, like what are the cells from which water can come to Indian Ocean. So from Indian Ocean will directly go to 3. Now from 3 will have to make the condition reverse, like the condition should be height I is greater than equal to height j. Only then it can go, because then we can come to 5, because from 5 if we go to 3 we go for the opposite condition, height I less than equal to height j. So the condition should be reversed here, right? The condition should be reversed here, and that's how we'll compute the reachability from both of them. So for example, these are reachable from Indian Ocean, this is also reachable, this is also reachable, this is also reachable, like that. So we'll compute the reachability. Similarly from Arabian Sea we'll compute the reachability, and finally we'll see if it is reachable from both. So we'll use a DFS for this, right? Visited 1, vector bool, visited 2, right? Now we'll check is valid. Is valid if a row and column is valid. In column, in row, in column, and also we'll take the last height, or let's not take the last height, row column. If row and also nm is needed, right? You can pass it here, n with m. If row greater than equal to 0 and row less than n, and column greater than equal to 0 and column less than n, then we'll return true, it is a valid cell, otherwise we'll return false. Also one more condition that has to be there, that is and not visited. It is not visited, or let's we'll do the visited later on, right? Okay, so return false. So we'll do the is valid. Now first of all, visited 1 equals to vector bool, vector bool, and of size of n, and it will be each cell will be of type vector bool of size of m, and initially everything is. Similarly visited 2, let's go to a full screen mode. Visited 2 equals to vector of bool of size m, size n. Each row will be of size m, so it will be a vector bool of size m, and everything will be false initially, right? So visited we have cleared. So first of all, let's consider the case of Indian Ocean, right? Indian Ocean. So here we'll do void DFS1 and DFS2. So DFS1 will go for int row column, right? So row column will mark the visited 1 row column equals to true. Also what we'll take here is we'll take the matrix as well, vector int. Actually it's better if we could have taken a class and done everything, but again, like, let's just pass in parameters one, int n, int m, right? Visited 1 is true. Then what we can check is so what are the directions we can move? We can move in 4 directions, right? So let's actually maintain the dx and dy's. So vector int dx equals to, like, in x direction we can move by +1, -1, so 1 1 1, +1 +1, +1 will not be there, so 1 0, -1 0, and vector int dy equals to 0 1 0. I believe these are the 4 directions, dx and dy. Okay. Visited. Now for int I equals to 0, I less than dx dot size, I equals to 0, I less than 4, I plus plus. Int next row will be rho plus dx of I. Int next column will be what? Column plus dy of I. Column plus dy of I. Now we'll check if is valid. If is valid, next row, next column, next row, next column, nm. If it is valid, after that we'll check if not visited. If not visited, next row, next column. If we haven't visited it yet, so next row, next column, and it will be visited one, right? Visited one, no, next row, next column. And then what is the second condition? The height condition. So the matrix of row column will move to what? Will move to a greater height. So less than equal to matrix of next row, next column, right? If that is the case, then we will run DFS1 on next row, next column, matrix n m. So this is the code for DFS1. Similarly, DFS2 will be very similar to this. Same thing. DFS2 will be the same thing, only visited array will be visited 2 instead. So this is DFS2. And here it will be visited 2. And here also it will be visited 2. And DFS2. Right? Okay. For Indian Ocean, what will be the condition? For Indian Ocean, what are the cells? The top and the left. So for int I equals to 0, I less than m, I plus plus. If not visited 1, 0, row and this column, we will run a DFS1 from 0 I matrix nm. 0 I matrix nm, I believe that is what we want. 0 I matrix nm, yes. So this is for the row. This is for a row, for the top row, and for the column, left column, for int I equals to 0, I less than n, I plus plus. If not visited 1, I 0, DFS1, I 0, matrix n m, right? So we are done with both for the Indian Ocean. This will be Indian Ocean. Indian Ocean starting points will be the top row and the left row. Similarly for let's do it for Arabian Sea. So Arabian Sea, what we can do for int I equals to 0. So it will be I equals to 0. Yes, I less than m, I plus plus. If not visited 2 of what? Visited 2 of row will be the last row, right? So n minus 1 I. N minus 1 I. In that case, DFS2 row, column, matrix nm. Similarly for the right column, so right column, I less than m, sorry, I less than n, I plus plus. If not visited 2 of I m minus 1, in that case DFS2 I m minus 1 matrix n m. And finally int answer equals to 0. For we'll see both of them are visited. For int I equals to 0, I less than n, I plus plus. For int j equals to 0, j less than m, j plus plus if visited 1 ij and visited 2 ij. In that case, answer should be plus plus, and finally return answer. So this is the code. Is the code clear? When you complete the Amazon series, are you coming back to POTD? Can't understand their explanation. I'm not sure because it is assigned to them. I'll talk to them. If that's the problem, you can raise the issue or you can write in the comment or something that you're not understanding. Okay, it is 8. Is it expected to be 8? I think I've calculated more. Oh, it is expected to be 8, right? So I think this is working fine. But yeah, if definitely write maybe write something, or I'll try on my end if I can take those. Okay, so this is also solved. Any doubts on this? Any doubts? I think the code is big, but again, like this understanding is very simple, right? The code is nothing but DFS, right? DFSing on a matrix. I believe, like, if you know about DFS or you have done DFS on matrix, then this should be nothing additional. The logic, I believe, should be clear. Is the logic clear? And or anyone has any doubts with how exactly things are working, or why have I done this? Anyone has any doubts with this? Dhananjay, I'll look into this, right? Anyone has any doubts? This code might be a bit complicated, but the code could have been simpler if I just created a class. It would have been much cleaner and simpler. But yeah, like other than that, it's just DFS code, right? It's just DFSing on a matrix. Is the logic clear with everyone? That's important. Code, I would recommend you to try it yourself once, because it's nice. Like, to implement these things is nice problem to implement. So just try it yourself once. Other than that, let me know if the logic is clear, what I have done here. Anyone has any doubts? POTD hard ones if possible. Okay, I'll definitely do. Okay. I'll definitely do that. Anyone has any doubts here? Or is it clear? I'm assuming that things clear. All right. Assuming that things are clear and there is no doubts, forward. Cool. Let's go to the last one. So this is the last problem. So the problem is Geek's binary search algorithm. Let's read about it. So Geek is fond of the binary search algorithm. To make it more interesting, last problem is yes. That's why I was thinking of taking this first before the grid one. But again, I saw the accuracy is very less. But yeah, it's pretty simple. And it's definitely not a hard problem. The implementation wise, it's not hard. It's a bit tricky. So Gig is fond of the binary search algorithm. To make it more interesting, he slightly modified the algorithm which is given as below. So the modified algorithm, if you see, low equals to 0, high equals to n minus 1, while low less than equal to high, till now it is same as binary search. Mid equals to random number, low to high. So this is different. Mid equals to, we generally do low plus high by 2, we take the middle element, but here Geek is taking a random number, right? So if a of mid equals to target, then return mid. else if greater than target high equals to mid minus 1, else low equals to mid plus 1. So everything is same as the binary search, only this part has changed, that instead of getting the mid, he can take any random number. Okay, so now you are given an array of size n and you need to find the number of elements which can be always found with this modified binary search algorithm. So what it is given to you, you are given the modified algorithm. The modified algorithm is different in terms of that the mid is can be any random number. It is not low plus high by 2, but it is any random number, right? Between low to high. Between low to high, it can be any random number. So you are given an array of size n. You need to find the number of elements which can always be found using this algorithm. Okay? So what are the elements that can always be found using this algorithm? So for example, 1, 4, 3, 5. What are the elements you can always find? You can always find 1 using this algorithm. You can always find 5 using this algorithm. Why cannot you find 4? Because let's say you take the pivot to be 3, right? Then you do what? You see 4 is greater than 3, so you do low equals to mid plus 1, and you cannot find 4 anymore, right? Similarly, you cannot find 3 because if you take the mid element to be 4, in that case you will do high equals to mid minus 1, so the search range becomes 1 to 4, so you cannot find 3, but you can find 1 and 5 always, right? So how can we solve this? I'll directly jump into the solution because it's very simple, right? It's very simple. First of all, we have to understand when can we not find a solution, right? When can we not find a solution? So, and when can we find, right? So let's say there is an element A, right? There is an element A, and the element A, we are saying that we can find it, always find it, right? We can always find it. What should be the condition for always finding A using the algorithm? Remember, we are choosing a random number between low to high, right? So that means that on the left hand side of A, I should have all the numbers less than A, because if any number is greater than A, let's say if any number is greater than A on the left hand side, if we choose that as the pivot element or the mid element, then our search range will be reducing to the right part, right? So we can never find A actually. So if we are able to find A, so on the left hand side of A, all the elements should be less than A. Similarly, on the right hand side of A, all the elements should be greater than A. If these two conditions are satisfied, then we can always find A. Is n log n really too strict for this problem? What is the constraint? 10 to the power 5. It should not have been strict. I'm not sure. Anyways, so what we have to essentially do, this is the condition, right? Just think about it. Let's say we are telling, let's replace A with some value, right? Let's say we are telling that we can always find 3 is here. We can always find 3. Let's say here a 4 comes in. Can we find 3? If this is chosen as the mid element, in the first iteration only, this is chosen as the mid element, so our search range will be reducing to this part, so we can never find 3. So definitely all the elements on this part should be less than 3. If it is less than 3, right, if all the elements, let's say it is 2, 1, something like this, right? So in any case, the pipe, if any one of them are the mid element, always we will go to the right part. Our search will always reduce to the right part, right? So 3 is definitely on the right hand side. Similarly, all the elements on the right hand side should be greater than 3. Let's say here is 2, right? So in this case, let's say the pivot or the mid element becomes 2. So in that case, what we would do, low equals to mid plus 1. So our search range would become this part, and 3 is not there, right? So what we should do have here is, let's say we have here 6, 5, 4, anything like this, right? So in any case, any one of them is the pivot, we'll always know that 3 is on the left hand side. So our search range would comprise of 3, right? Our search range would comprise of 3 always. So the condition for, okay. So the condition for a element to be always found is all the elements on the left hand side of this element should be less than this element. All the elements on the right hand side of this element should be greater than this element. Only exception is for the starting element. to be found, it should be minimum element. The ending element to be found, it should be the maximum element, right? So these are the only two exceptions. Starting element should be minimum, ending element should be maximum if we are to find the starting and the ending element. So that is the condition for any element, right? For any element we have to satisfy this condition. So how we can satisfy this condition, how we can ensure that all the elements before a are less than a? By maintaining a minimum prefix minimum. All the elements are greater than on the right hand side by maintaining a suffix maximum. So we'll maintain a prefix minimum or suffix maximum. Let's understand what do we mean by this. So can we take a better example? 1 2 3 4. Let's say we have something like this, that two, 1, 3, 5, 4. So in this case, prefix minimum will start from the left, and the formula will be prefix min of I equals to prefix min of I minus 1 or a of I, the minimum of. So for 2 it will be 2, for 1 it will be 1, for 3 it will be the prefix minimum will be, sorry, my bad. So on the left hand side we don't need the prefix minimum but the prefix maximum, right? Because all the elements should be less than 3. That means the maximum element on the left hand side should be less than 3, not the minimum. The maximum element on the left hand side should be less than 3, right? So we'll compute a prefix maximum. Similarly, for the right hand side, all the elements should be less than 3, all the elements should be greater than 3. That means the minimum element should also be greater than 3. So that will be suffix minimum. So prefix maximum will maintain 2, then 2, then at 3 it will become 3, then 5, then 5. So this is how the prefix maximum will look like. The suffix minimum will start from the end, 4, at 5 also 4, at 3 it will become 3, at 1 it will become 1, then it will become 1 again, right? Now see, for 3, this cell, right, for this part, the prefix minimum of the previous prefix maximum of the previous is 2. So all the elements are less than 2 on the left hand side, and 2 is less than 3, so all the elements are less than 3 on the left hand side. The suffix maximum for the next element is 4. So all the elements, suffix minimum of the next element is 4. So all the elements on the right hand side are greater than 4, and 3 is less than 4. So that means all the elements are 3 is less than all the elements on the right hand side. So we can accurately find this. Okay, I'll explain again. So I think the problem statement is clear, right? So we can choose any random number, right? We can choose any random number instead of mid element. We can choose any random number in the range low to high. So we are saying that what are the elements that we can always find? What are the elements that we can always find using this algorithm, binary search algorithm? We can find the element A, right? We can find the element A if and only if all the elements in the left hand side of A is less than A. All the elements on right hand side of A is greater than A, right? Why so? Let's assume A is 3, right? A is 3. So if we have a element on the left hand side that is, let's say 4 is greater than 3. So let's say in the first iteration the random number selects 4 as the mid element. So in that case our search range would reduce to this part in which 3 is not available. So this will not work. Only when all the elements are less than 3, that is, let's say 2, 1 or something like this, in these cases whatever is the pivot or whatever is the mid element, our search range always shifts to the right hand part in which 3 is available, right? Similarly, all the elements on the right hand side should be greater than 3. That means, let's say there is 1 here. So if this is chosen as the mid element in the first iteration, so what we'll do, low equals to mid plus 1. So our search range would reduce to this part, right? Our search range would reduce to this part. So we would not get 3. So we should have only elements that are greater than 3 on the right hand side. So let's say anything it is there 5, 4. So if any one of 5 and 4 is chosen as the pivot, we'll know that 5 or 4 are greater than 3. So the 3 is on the left hand side. So our search space would reduce on the left hand side in which 3 is available, right? So that's why for any element A to be found, all the elements before A should be less than A. All the elements after A should be greater than A. So can we simplify this statement a bit? So all the elements are less than A. That also means that the maximum element in this range, the maximum element in the first half should be less than A. All the elements are greater than A. All the elements are greater than A. That means what? The minimum element on the right hand side, should be greater than A. In that case, all the elements will be greater than A. So we can maintain the maximum element on the left hand side or the minimum element on the right hand side using prefix and suffix. So we want prefix maximum and suffix minimum. So once we compute that, we are done with the problem. So let's try to write the code for this. I think it will make more sense when you see the code. So in prefix max of size n, in suffix min of size n. Okay. Prefix max of 0 equals to ARR 0. For int I equals to 1, I less than n, I plus plus. No, we don't have to use min heap or max heap. We just need prefix suffix. So prefix max of I equals to max of prefix max of I minus 1, comma ARR of I, right? So this is prefix max. Suffix minimum, similarly, suffix minimum of n minus 1 is equals to ARR n minus 1. For int I equals to n minus 2, I greater than equal to 0, I minus minus, suffix min of I equals to min of suffix min of I plus 1 or ARR of I. Now int answer equals to 0. So for except the two corners, for all the middle elements, for I equals to 1, I less than n minus 1, I plus plus, I plus plus. If ARR I greater than the prefix max, ARR I is greater than the prefix max of I minus 1, and ARR I is less than the suffix mean of I plus 1. In that case, we can find it. So answer plus plus, right? Similarly, for the first element, if ARR 0 is less than the suffix mean of 1, in that case answer plus plus. If and also if n is greater than 1, and similarly if okay, for n equals to 0 we can so if n equals to 1, we can return 1 directly. So n equals to 1, we can return 1 directly. So the array size is at least 2, right? So we don't need this condition. So similarly for the last element, ARR n minus 1 is greater than the prefix max of n minus 2 elements, first n minus 2 elements, then answer plus plus and return answer. For each position, we are finding the prefix max. Prefix max means what is the maximum value of all the elements from 0 to I. What is the maximum value for all the elements from 0 to I? So how can we find the prefix max? Prefix max means prefix max of I. This means maximum value from 0 to I. So how do we calculate this? Prefix max of I, it can be whatever, it will be the maximum of either the prefix max that we have found till I minus 1 or ARR I. So that is the definition of prefix max. Similarly, suffix mean is what is the suffix means from the end. Suffix mean means minimum value from the end to that index. Minimum value from end to that index, right? So I'll write down this for prefix and suffix max, and I think that will make things more clearer. So let's compile and run. Our output is 2. Let's submit. Okay, so this is also solved, right? Let me just quickly write on this on some example. 1, 4, 3, or we'll take an example. Let's say 1, 3, 2, 4, 6, 5, right? So we are computing the prefix max and the suffix min. So what is prefix max again? This is suffix min part, right? What did we do? Prefix max. Let's actually skip that part. Prefix max. Let's snip this. What is the array? 1, 3, 2, 4, 6, 5. Okay. So what is prefix max? Prefix max of I, prefix max of 0 is ARR 0. Prefix max of 0 is ARR 0. So for 0 it will be 1. For 1 to n, prefix max of I is max of prefix max of I minus 1, comma ARR of I. So for 1 is 3 greater, or prefix max of I minus 1, there is 1 greater. 3 is greater, so it will become 3. For this index is 2 greater, or prefix max of I minus 1, that is 3 greater. 3 is greater, so it will remain 3. For this index is 4 greater or 3 greater. 4 is greater, so 4. For this index 6 is greater, so 6. For this index 5 is greater or 6 is greater. 6 is greater, so 6. So see, prefix max of I at any index I, it will be the maximum value from 0 to I. So let's consider this index. So 0 to this index 2, what is the maximum value? 3. So 3 is there, right? So that is prefix max. Now suffix mean, we'll do the same thing. Suffix mean. So suffix mean of n minus 1 is ARR n minus 1. So this will be 5. For I equals to n minus 2 to 0, suffix mean of I will be minimum of suffix mean of I plus 1, comma ARR of I. So suffix mean of this position will be minimum of suffix mean of I plus 1, that is 5, or current element, that is 6. So minimum is 5, so 5. For this position, minimum of current element 4, or the suffix mean of I plus 1, that is 5. So 4 is minimum, so 4. For this position, right? Sorry, this is the array. For this position is 2 minimum or 4 minimum. 2 is minimum, so 2. For this position is 2 minimum or 3 minimum. 2 is minimum, so 2. For this position is 1 minimum or 3 minimum, so 1 is minimum, so 1. 1 minimum or 2 minimum, 1 is minimum. So just see, for any index, let's say this index, this will give you the minimum of the range in this index to n minus 1. The 4, 6, 5, the minimum is 4, so 4 is there, right? So that is suffix mean. Now we have we are computing these two, and now we can see the answer. What will be the answer? So we check for I equals to 1 to n minus 1, and ARR I is greater than prefix max of I minus 1, and ARR I is less than suffix mean of I plus 1. So we'll start from here. Is ARR I 3 greater than prefix max of I minus 1? Yes. Is ARR I, that is 3, less than suffix less than suffix max of I plus 1? No, 2 is there. So this is not, it will not do answer plus plus. For this also it will not do answer plus plus. For 4, is the prefix minimum, that is maximum, that is 3, less than 4? Yes. Is the suffix minimum, that is 5 for I plus 1, less than 4 or greater than 4? Yes. So this is answer plus plus. So here we do answer plus plus. Pseudocode and try to implement my whole logic into no, random number generation and kind of that, it won't work, right? You have to find a deterministic algorithm. Anyways, this is how we can solve. I think this is clear with everyone. Is this clear with everyone? What is the condition for an element to be determined perfectly, or how can we determine an element? And let me know if this is clear. All right. So yeah, that's about today. Thank you guys for joining in, and I'll see you in the next class.